Hey guys, um, this is session 4 of the Python 4 Revit class. In the previous session, we touched upon basic concepts about databases and how we can use those to kind of like understand Revit better. In this session, I'm going to show you how to actually make a transaction and make a change in sort of like in the Revit file in a Revit document. And this is going to be sort of like the introductory, the basic course that we're going to talk about transactions and how we actually make changes in Revit environment, in a Revit document. So as an example, let's say I have this document open with a bunch of walls in it and with a couple of sheets. And I have also defined a shared parameter, actually a project parameter. It's not a shared parameter. Calling it custom parameter that is defined for sheets only, and it's of type text, and it's basically it belongs to all the sheet objects in this document. So all of them have this custom parameter that I've defined for this model only. We are going to do two transactions. One to write a value to this parameter for all the sheet objects, and another one to delete these walls. And then I'll show you later how we can group these two transactions into one action that does two things in basically in one action. So to get things started, we're going to talk about we're going to start from the script that we made in the session 2, which we basically use this script to collect all the walls in the document and read the value of the volume from them and do sort of like a calculation of what's the total volume of all these walls. If you want to see that script, you can go under pyRevit extensions here and then activate the pyRevit tutor tab extension, and that total volume calculator is basically there, and you can run it at any time. It basically tells you what's the total volume of all the walls in the model is. For each one of the sessions, each time we create a script, I'll basically add it there as an example. And if you want to see the script, you can hold the Alt button and click on the sort of like the button, and then it points you to the script, and you can open it, and you can see what the script is, and copy stuff from it, and modify it to create your own. Anyway, I'm going to use this as a sort of like a starting point. So some of these stuff are related to pyRevit, like these, if you want to see the video that I did on creating this tool, adding this tool to pyRevit basically. But what we actually need in here is really this part of it. I'm just going to copy that over here just to kickstart stuff. Okay, this is a file that I'm going to call it sheet parameter, which is we're gonna use this to make changes to the sheet parameter. So the first thing we want to do is we want to create a sheet collector, right? We want to collect all the sheets using the filter element collector that we talked in session 2 on this document of category of the sheets. So what I have to do is I have to go to the Revit API docs, and I want to, oh, that's the wrong spot. Actually, it wasn't that bad, but, and I'm gonna call built-in category. Okay, so I need that enumeration. Well, let's use the 2017. Yes, that. And I'm going to search for, because I know all of them start with OSD, I'm going to search for OSD sheets, maybe. Oh, yeah, there we go. So there's one here that is a built-in category that basically describes all the sheet in the model. So I can use that instead of the OSD walls. I'm going to always collect all the sheets. And then I'm going to also add this that says where element is not element type, because I don't want to collect the sheet types. I just want to collect all the sheets that are in the model. And to make things simpler, I'm going to add another filter to it which says two elements. I'm going to make this a little bit bigger. Two elements. A lot of times this gets a little bit longer, so as the line length gets longer, traditionally you could break your so after the category you can break your line by adding a slash at the end and then hit enter, and then this is what I do generally, and I do this and break it here as well and then do that. So this is a little bit easier to read and understand. That filter element collect all these sheets and then filter down to the ones that are not the type and just give me the elements. You could use the element IDs also. I'll explain what the element ID is and stuff like that later, and we get to it and we use it more. But for this one, I want the actual sheets, not their ID. So we basically created a sheet collector, right? I'm going to take this note out of here. Okay, so we have the sheets. So what I want to do is that I want to iterate over these sheets and get a value or the parameter that is this, the custom parameter that we made for the sheets. I want to write a basic value to it. So I'm going to also use this piece from my previous script that we used to do that. And I'm going to say sheet collector instead of wall collector, and give me a sheet. I don't need, well, I kind of need those. So I'm going to say sheet lookup parameter because we want to look up a parameter that belongs to a sheet. I'm going to type the parameter name, and we're going to call this, instead of volume parameter because it's not volume parameter, we're going to call it the custom parameter. And we want to make sure that there's something returned from this custom parameter. If the custom parameter exists, then here's where this is new to this course. Up to this point, we talked about in the first course that we're just collecting data from Revit. This is the part that we want to make changes to it. So the custom parameter points to a parameter object right now that has been returned by the lookup parameter function. So let's dig into this a little bit more and see what's going on. Let's go to Revit API docs and say lookup parameter. So there's a lookup parameter method that belongs to the Autodesk Revit DB element, which is the master parent element for all the elements in Revit. So you can look up a parameter. What it returns is a parameter object, right? So if you click on it, and I actually can use this to kind of, oh, I lost it, I think. Anyway, scroll down and say parameter members. Okay, so this is the parameter object. So this value, if something is returned, this is the parameter object that we're talking about. So what I can do is that I can get its value as a double, as an element ID, as an integer, as a string, as a value string, and I explain to you why these two are different later. And we can do a bunch of other stuff on it. But what's important to us for now is the set methods. So there are 4 different versions of the set and one that says set value string. Let's talk about these. Python, by its nature, is not a type-safe language, meaning that whenever I want to use let's say I want to assign 3 to a variable, I can say my variable, let's call it whatever, Ehsan, my name, and then equals 13. We just assign that, and later we can do Ehsan equals a string. This is totally valid in Python. In other languages, especially C#, you need to say that int Ehsan, you need to declare your variable before. And you need to tell the programming language, tell the compiler that this variable is of type int. It's an integer. And then you can do that and assign an integer to it. And later, if you want to try to assign a string to it, then you get a compiler that, oh, Ehsan is of type integer. You can assign this to it. This is what is called a type-safe language. It controls, you basically declare all the types of your variables, and later on it helps you figure out, it helps you not to associate like other objects to that variable. And that means that when you're creating a method, for example, for one of your objects that wants to get a variable as an input, let's say parameter value, if this is an integer parameter, this needs to be defined as an integer value. If it's a string, it needs to be a string value. If it's other type, it needs to be other type. So these are called overloads. So you have 4 different versions of this. It's the same. There are actually 4 different methods, but as far as we care in Python writing program for Revit, they're all the same to us. Based on the type of the input that we provide to the set, the IronPython engine behind the scene will pick the right overload to use. So if you provided an integer, it's going to use that. If you provide a string, it's going to use that, and things like this. It also depends on the type of the storage type of that variable as well. So sometimes this for doubles and integers, like an integer set double also set for a double, the set integer also works. But what is really important is because you define the type of content that this parameter can accept. Like this is a text. You can't put an integer in this. You can type it like this, but this is not being saved as a number. It's going to be saved as a string, right? So it kind of depends on that as well. But for the sake of us just know about their existence and how you can read it from the documentation, like if you see this, it means that, okay, I can provide these 4 different things to the set and it will work. So for our case, we want the set with the string because our parameter is of type text and it means that it can accept strings. So what we're going to do in our script, we're going to say custom param set, and see, I'm using the capital S because that's how the method is defined, right? And I'm going to give it a value of a string, example value. So we created this and use the set to assign a string value to that parameter. And basically all we're doing is that we have collected the sheets and we're going to iterate over them, pick each one from the list, from the collector, look up the parameter, that specific parameter, show there's a return value, there's this parameter that has been returned to us, and set it to a value. That's all we need to do, right? That's what we think that's all we need to do. So we save that, and I'm going to go back here, and I'm going to run that in Revit Python shell. Let's see what happens. We did that. Looks good. Run. Oh, we got an error. What does it say? It says Autodesk Revit exception, modification outside transaction exception. So this is why it ties to the previous discussion that we had about databases and the examples that I told you about transactions. We are making a change to the Revit database. We need to start a transaction to do that because Revit needs to, we are making changes to it and we have to make sure that nothing else is actually doing that. So these changes are the ones that require a transaction. So let's go do that. Let's start a transaction. So to do that, I also need the transaction object. And if you don't know about this, please watch the previous video, the session 3 video that we talk about the basics of databases and the transactions. So I'll import that, and this is how we use it. Actually, this is a little bit annoying. T equals the transaction in this document, and let's call it update sheets, sheet parameters. Okay, we created a transaction object. Now, we need to start a transaction. And pay attention that I'm doing both of these actions before I actually, before I actually start making changes to the parameters. And also see that all of these changes that I'm doing to all the sheets, I'm encapsulating all that in one transaction. So this is where I start a transaction, and this is where I'm committing the transaction. So I'm starting a transaction, going through all the sheets, updating the parameter values, and then when I'm done, I'm going to trigger the commit, and I'm going to commit the transaction, letting Revit know that I made all the changes, you're good to go, make sure that the database is safe, and then tell me if I have any errors and stuff like that, right? Okay, so save the file. Let's do this. Let's do this. Open this, and open the file, and now do it. And oh, everything went through. We saw the next command, and we can close this, and we can see the custom parameter has the new value in it. And if I click on any of these sheets, it has the example value that we gave it. So the change has been applied. We didn't get any errors. Everything went through, and nice. Now, imagine you want to undo this. So if you open this, the undo menu, update sheet parameters. This is the name that we gave to our transaction. And that's what shows up on the undo list, basically. This is the transaction that was completed. So I can undo that, going to the previous, lose all that, And if I go to the redo, I see the same thing. So I can click that and I can redo all these two, right? So that's why we start a transaction and make all these changes inside that, because this way we make sure that nothing else obviously makes any changes to the database at that point. That's extremely important for Revit. There's no other way you can do this really. This is a rule enforced by Revit. And at the same time, you provide a nice encapsulation around the actions that you want to do. So Revit can provide a nice undo and redo system as part of the standard part of the software. And you as a programmer don't really have to, worry about this. So this is a very simple example of a transaction. And honestly, it doesn't, for most of the actions and most of the things that we do daily, it's not really gonna go, further than this. But let me know if you have any other questions. You want to know more about this. We're gonna obviously in the advanced sessions later, we're gonna more talk about like handling errors inside this loop that we are making some changes. If any error occurred, we want to make sure that we're gonna roll back our transaction, cancel the changes that we have done and stuff like this. So we'll talk about more advanced concepts in the future. But for now, if you want to make some basic write some basic scripts and update things in the Revit model and update the value of your standard company parameters and stuff like that, you can actually use this. This is as simple as a transaction gets, really. So for the second example, let's create another collector that collects the walls again. So it's actually going to be nice if I can just copy that instead of fixing it again. So let's do that. The only thing I want to add is this to element at the end of it, just to make sure that if I want to delete all the walls, I want to make sure that I'm deleting all the walls, not all the wall types, right? So this needs to exist also. So let's do that. Let's organize these lines nicely. And then do that at the end. Oh, delete it. Okay, so this looks a little bit nicer, and that's our wall collector. Now, okay, let's do this. And oops, what am I doing? Let's copy that. Let's go over the. Oh, this is annoying that Notepad++ does, but anyway. Oh, damn it. Okay, so wall in the wall collector. We don't need parameters now. The only thing we want to do is to delete the walls. That's what we really want to do. So before we actually start doing this, let's copy this and make sure we do all these changes in a transaction as well. I should actually go in settings, preferences, and turn off this auto tab that it does before it drives me crazy. I have forgotten where this was in the settings. Auto indent. Okay, close that. Did I save it? Didn't have a save. Okay. Okay. Let's paste that there. And paste the. We don't need that. We don't need that. We just need the commit here. Okay. Okay. Gorgeous. Now this transaction is a different transaction, so make sure that give it a proper appropriate name. Deleting all walls. Okay. Now, how we can delete things? There are a lot of things that we kind of have to learn by doing and by looking at other people's script and reading the documentation and stuff like that. Honestly, I always find things by just looking into the Revit API docs and searching for things and see what I can do to make that task happen. Most of the times I just run a search online and see what I can do, what's the script, how I can interact with Revit to make it like create a new instance of an element, or delete it, the element, or do other actions, or create a new floor plan and stuff like that. My hope is for these sessions, so I can, in the future, I can actually show each one of these to you, how you can create things and, update things and delete things and stuff like that in specific ways. As far as deleting goes, if you search for delete, a method comes up that is called the delete method, which belongs to the Autodesk Revit DB document. So if you click on that, and I'm gonna actually go under the document class so I can see all different methods of this delete. So see, the document class has a delete method. It's actually, there are two different overloads of this. One of them accepts only one element ID. The other one accepts a list of an I collection of element IDs, right? For this one, for this session, we're just going to use that for now. So document delete method gets an element ID and deletes that object. What's very important is that look at what it returns after the delete. It returns a list of element IDs. And what are these? It explains in the remarks what those are, but basically, whenever you're deleting an object, you might cause deletion of other elements as well. For example, if you have a wall that has been dimensioned with like two different dimension strings and has a window hosted on it, when you delete that wall, you're basically deleting two other dimension strings and a window. So this return value really gives you a list of all the elements that got deleted because of deleting this element. So if you have a huge list of stuff that you want to delete and you want to go through each one of them, you really are supposed to check the return value and make sure that to clean up the existing list of stuff that you have against this. So if you have, for example, uh, selected the wall and the window, and you want to delete both of them, and you go through the first action and delete the wall, Revit will delete the window also because it's hosted on that wall. So you don't have to really ask for another deletion for the window because it's already deleted. As a matter of fact, you get an error from the delete that this element doesn't exist anymore. So it doesn't make sense to it to delete. So you kind of have to check for that. So every time you do a delete, make sure you get the return values and check it against the list that you have and remove the ones that have been already deleted. So you don't ask Revit to delete those deleted elements again. For this one, we're just going to delete the existing wall, so I don't really worry about it. None of them are hosted on other ones and stuff like that. So I'm just going to say document delete, and I'm going to give it the element ID. And in the example before, I used the two elements on the collector. On this one, I'm going to say two element IDs. And if you go and look at the definition, the documentation for the filter element collector class in the members, these two methods, excuse me, that's what it does. That's what they do. It returns, so whatever you collected here and then filtered with these other filters, then you make a decision. Do you want to get the actual element objects, or do you want to get the element ID objects? I think I talked about this before, but one of the most important things about elements is their element IDs. And kind of sort of like referring back to the previous session talking about the databases, that element ID is the ID that uniquely identifies that single element inside the whole Revit model database that you have. So there's only one element with that element ID. And I'm going to show that to you here on the, let's go open another one of these tabs and look at the element class. I'm going to look for the element class, because there are actually two of them that I want to show you and kind of like explain the differences here. Am I on the wrong? Oh no, I'm looking at the properties. Okay, so let's look at the properties. Those are, I was looking at the methods. So there is ID and there is unique ID. ID is a short number. Basically, it's a unique identifier for an element in an Autodesk Revit project, right? The difference between this and the unique ID, which is a stable unique identifier for an element within a document, the difference is being stable. This means the unique ID is a much, much longer number. It's actually UUID. It's a much bigger number. ID is just a, is an integer really. The difference between these two is that this is good for whenever you are interacting with a bunch of elements inside your script, right? So if I want to do lots like this, read a bunch of elements, deleting them, passing information and element IDs between different functions of Revit and stuff like that within the same sort of like the script that I'm running to make some changes, that's fine. The challenge comes in, and if you want to store information about a Revit element, for example, let's say I want to export the volumes of these walls to a text file. And I also want to export the ID number so that later I can, for example, cross-check, load that file again and say, oh, okay, which one of these walls now has a newer volume, right? The volume, which one of these has changed? If you want to store information about this, you can store the ID of the object, but you really shouldn't store this ID. You really should use the unique ID, because the difference is that this is stable. So if you have this model and open it every time in different days and different Revit sessions, Revit guarantees that the object ID that it provides to you in the unique ID will stay the same no matter the shape of that object and where it's located and stuff like that. As long as it's the same object, if I change the size of it and do other stuff with it, the unique ID will stay the same, right? The most important part is that we assume that you update this Revit model from 2017 to 2018. That's where the important thing comes, that the unique IDs are guaranteed to be the same, not the IDs. IDs possibly could change. Most of the time it's fine, but Revit cannot guarantee that this ID will remain the same all the time. So if you're within one script, use the ID, that's fine. It's you're within one session and you are basically just dealing with passing information about an element just by passing its ID. But if you want to store information in a separate file, in a text file or something about some information, make sure you use the unique ID, because this is the one that if the model changes, if it's going to get updated to the 2018 version or a different version, this unique ID is guaranteed to be the same. And all this information that I'm basically telling you is described in this remarks under the unique ID. It tells you that the unique ID can be used to store an identifier in an external database and to retrieve the same element in the future if it still exists. The ID can be passed to the documents element property to retrieve the element. The unique ID is stable across upgrades and workset operations such as save to central and stuff like that. So this is guaranteed to be the same for the same object at all times. For this case, what the actual delete function wants, I think we lost that page. What the actual delete method wants is the element ID. So we should really get that and pass that to the element. So let's do that. What we're going to do is that in our script, we're going to say delete. So this is the wall element that we have. What I asked the collector to give back to me is all these element IDs. So I don't have to do wall.id because the wall is really wall ID. So I'm going to actually say wall ID collector, let's say, because it's not collecting the walls, it's collecting the wall element IDs. And this is going to be a wall ID. And then I'll pass it to the delete method and we'll delete that. So I'll just save that. So we have one transaction here, basically here, one transaction to update the sheet values and another transaction to delete the walls. Okay, so let's run that and see what happens. Okay. Oh, there are no walls and the value on the sheet is updated. Okay, so we completed both transactions. Now I'm going to go back and I'm going to go back to here because we updated that. Let me actually run this again. Okay, let's run that again after the cleanups because I changed the size of that wall and stuff like that. So I had a bunch of other actions completed. Okay, so see, these are the two transactions that we did: update sheet parameters and delete all the walls, right? Okay, so I'm gonna undo this too. That's clean. They're not here anymore. Perfect. They moved into redo. That's fine. Okay, so I'm gonna show you how you can combine these two, because you saw that we did two transactions and there are like two transactions in here. So if one of your users, if you put this in one tool and they run the tool and they basically both do these two actions, and then later they want to undo, they actually have to undo two different things, right? As you saw that I undid, because they're really two different transactions. What we want to do in the next step is we want to combine these two in one transaction. So for the sake of simplicity, I'm going to move this to the top. Say we collect the sheets, we collect the wall IDs, and now let's start making changes to the model, right? What we're going to do is that we're going to import a transaction group object. And you can look at the Revit API docs for what it does. Let's actually take a quick look at it. "2017 is fine. Let's look at that. I'm going to go under members. Cool. Okay. So it's very similar to transaction if you actually look at it. So I can give it a document and a name to kind of like create the transaction object. And I have a start, I have a commit, and there are a bunch of other methods. There's one that's unique to this, which is called the simulate. Simulate all inner transactions by merging them into a single undo item. That's exactly what I wanted. So what I need to do is to create a transaction group and say transaction group, just like the transaction. See, I'm not getting rid of my own transactions, right? These two will happen inside this transaction group that we are creating, and we're going to give it a name. Let's say update sheets, update and delete. Let's just call it update and delete, right? Transaction group. And I need to start the transaction group just like we start a transaction, and then when we go and start that later, we start a transaction, the first one. We'll create that, start it and end it, and then create the second transaction, start it and end it, and then close the transaction group here. And we're going to close it by not committing, by assimilating. And that means that, as it described, these two transactions will be assimilated, will be combined into one action in the undo menu there, right? So I'm going to save that, and then I'm going to open this again, open the script and run it. Everything was done, walls were deleted, and now when I open this, I only see the update and delete. So if that was one tool that I used here and I clicked on it and it did a bunch of stuff, now there's only one entry in the redo and basically in the redo menu that relates to that. And that is the way it's supposed to be, because you don't want, the user doesn't really need to know how many transactions you're doing inside that tool to make the actions that you want to do. They just want to see that, right? Because if I want to undo it, I don't have to know that I have to undo like 4 different actions that you did inside that script. I just need to undo one. So it's a very good habit to combine your transactions into one, so that the user has a nice sort of like, one single click here that they can undo those actions. So see, I brought back cleaned up the values again by undoing it and brought back all the walls. And if I go back to the script, we collected the walls, the sheets, we collected the walls, so we did the read action on our database, and then we started transactions, a transaction group, and another transaction inside it, which we updated certain sheet parameters, and we actually deleted also a bunch of objects. So we did read, update, and delete on our Revit database, basically. So from now on, I'm going to, sort of like keep this habit of referring to Revit's document as sort of like a database and the transactions and the changes that we do for a little while. After that, we're going to start, getting dig deeper into how we can create different types of elements in Revit, and we can, get specific types of information from the Revit model and stuff like this. And the most important part is that what part of this API we can use to get the information, to update the information, to create the certain objects that we want, or to delete them. As far as deleting goes, that's pretty much it, the document delete. But as far as updating and reading the values and stuff like this, there are a couple of different things that we need to know to sort of like get into the advanced levels. Thank you for watching this. I'm gonna hopefully post another session soon on creating a bunch of standard elements in the Revit document, just to have the basics of creating things in Revit document as well going on. So we would complete the sort of like the basics videos of creating, reading, updating, and deleting. And then later, we'll start digging deep into more advanced tasks and things like that. Thank you.